Everybody, welcome to this session for understanding and troubleshooting SQL in Cognos Analytics. So the topics that we're going to cover today is let's start with the basics of where do we find the SQL. So there's multiple locations that we'll take a look at, how and when we would look at those locations for the SQL, how we would set up a JDBC trace for the more complex scenarios of troubleshooting. And then we'll take a look at basically a basic example, very simple report and what the SQL looks like and compare differences between Cognos and native SQL, that type of thing, and understanding what the difference is. Then we'll take a look at cases where you might have split SQL and how that can affect your performance and what we can do to mitigate or at least try to reduce the performance hit that you might take in those situations. And that will be done through optimizing joins. And then we'll take a look at a single fact query. So basically it's like this whole presentation will be like a building block. We'll start from simple and we'll work our way to more complex. So we'll see what a single fact query looks like. So that's dimensions with one fact table. And then we'll add summaries to that to see how the SQL changes so that you can understand why all of a sudden you're starting to see more subqueries occurring. And then we'll take a look at more complex scenarios with multi-fact queries. And then we'll introduce non-conformed or non-shared dimensions in those multi-fact queries to see how that then also increases the amount of SQL and what the differences are. And how to ensure that you configure your models correctly so that you don't get incorrect aggregations for facts that are at different levels of granularity. And then where did that come from? So if you see stuff in the SQL that you didn't expect, we'll take a look at that. And well, I think I might have jumped ahead there. So the double counting kind of goes in with some of the non-conform dimension stuff, but we will take a look at all of that probably in the order that you see there. So most of this is going to be, well, actually all of this is going to be live demo. So if something does go wrong, bear with me as I work through it. But you'll know that there's no smoke and mirrors happening here. So starting off with the topic of where do we find SQL? So let's actually start off. We'll start off with Framework Manager. Everything we're going to do in today's presentation is going to deal with dynamic query mode. Okay, we're not going to go back and look at CQM and all that SQL generation. We're going to focus on the newer query engine. And we'll mostly focus on data modules, but I do want to show for completeness where you would find these things in Framework Manager as well. Okay, so first spot that you'd want to look for SQL is, so first off, you're going to, in Framework Manager, you'll see SQL that's on the SQL tab. Okay, this is the SQL that's used to pull metadata and data from the database. So this is what you design. But when you're troubleshooting what we generate at query runtime for reports, et cetera, or for the things that you've designed in your model, you are going to go to the Query Information tab to view that SQL. And if you wanted to emulate what's happening in the studios, because we auto-sum and aggregate by default, you'll click this auto-sum, and that will give you a more accurate representation of what happens in Cognos Analytics. And then you click Test Sample here, and it'll show you all the columns that are brought back. And this is the Cognos SQL. And then you'll also see the native SQL. Okay, and we'll get into some differences of that a little bit more in a few moments. Okay, when you do it here, one of the things that I wanted to draw your attention to is that if you go directly to the Query tab rather than the Test tab, if you click the Test tab and then click Test Sample, we'll actually bring back data. So you're actually creating the database, and now there's a little bit more processing. But if you just want to see what the SQL is doing, if you click directly on the Query tab and then click Test Sample, we are going to send something down saying fetch first 0 rows, or you can see here in the native SQL, select top 0. So we're not churning or crunching data on the database side. You're just getting to see what the query generation would be. So that's a little tip. Okay, so that's one way. Also, you can see SQL generation even on the joins. If you go to Relationship SQL, you can test it here, and then you'll see the SQL that is when you join two tables together. So multiple locations that you can see this. So everything you do, whether it's a data source query subject or a model query subject, it's the same concept. You can go to the Query Information tab and test and see your SQL. Okay, so that's Framework Manager. Looking at data modules. So in data modules, you can simply right-click on a query subject or a table, and you can say, show the query information, and that will show you the SQL that is used for that table. And here it defaults to the Cognos SQL. And then you can also go and select the native SQL to see that. So one of the things that I'll just draw your attention to quickly here is that if you look at the Cognos SQL, first of all, you won't see the quotes around all the columns and everything that's selected. But more importantly is that you'll see here, this is the data source or the data server name that was configured in Cognos. And that's followed by, in this case, it's a SQL Server database. So this is the catalog. And then you'll see the schema and then the actual table. So depending on the vendor, you may or may not see the catalog. So you might just see ... and then the schema. And if you switch over to the native SQL, you'll notice that the data server connection or the data server name that's configured in Cognos, it does not appear here. You just see the catalog and the schema, and that's the difference. So that's why if you try to take Cognos SQL and you copy this and try to run it directly against your database, you'll get an error because it won't understand what this is. Again, just another quick tip. Okay, so that's another way to look at SQL. Now, we'll take a look at going into the into some of the studios. So if we go look at, let's say we want to figure out how to find SQL in a dashboard. So we'll just go and create a very simple dashboard here. I'm going to keep this very straightforward just by dragging this on. So we have a serviceability panel that we can invoke. When you select the visualization, if you click Control period on your keyboard, it will pop up this serviceability panel, and you'll have this query section here, and you can turn on Fetch Query, and then you can click on the Show SQL and MDX. Okay, and again, the same thing. You'll see that you have the Cognos SQL and the native SQL. And then conversely, in reporting, we'll just, again, do something very simple. We'll bring in product line. So in reporting, there's two different locations that you can, well, actually three technically, that you can get SQL from. So one of them is from here. Now this show generated SQL and MDX. This is what you would use by and large for your troubleshooting, because this is what is actually going to be sent through the JDBC driver at runtime, because it will include any sorting, grouping that you do in the layout of the query. So this is the most accurate SQL that will be sent off to the database. And again, native SQL, Cognos SQL. All right, and a little trick that I want to show is if you look at this scroll bar here, when you switch between the two SQLs, you can see them jump back and forth, but look at the scroll bar. And if the scroll, and I think we have a little bit of word wrapping. So make sure there's no word wrapping going on. And then if you switch back and forth, if you see a little bit of a jump in the scroll bar, there might be cause for you to go and look. Now it could just be a line wrap or whatever. But typically, when you see a great jump in the scroll bar, that means there's a lot more SQL in the Cognos SQL than there could be in the native SQL or vice versa. And that is a cause for investigation. Again, it's just a little tip. In this case, I think the SQL is pretty accurate and pretty similar. So we're just seeing a minor jump in the scroll bar size. Okay. Another place that you can find SQL is if you go directly to the query, and you can actually generate the SQL Now this is called the tabular SQL. So you can actually generate it from here, view tabular, this is view tabular data. So that here you're just going to view what comes back from the data items that you have in the query. And this SQL here will also show you what SQL would be used to bring back that tabular data, not the overall data, but the tabular data. All right. Now to highlight that or to draw more attention to that, I'll take a simpler test case here of a table that I know. This is an uploaded spreadsheet. So this is technically a data set in the content store, but we still use SQL to query against that. And if we look at the query for this, you'll notice it's very straightforward. You're selecting product from this spreadsheet and you're grouping on the product name. And if you go look at the tabular data in that query, it will be the same. Okay, very simple. However, if I go back to the page and I decide I want to add a sort to it. Now, if I look at this query, I have an order by. But if I go back to the tabular data, it will be the same as it was before. Okay, so that's just to highlight the difference of what's the difference between those two. And another way that you can do this, and maybe the example that I'll take for this is I'm going to launch a dimensional source. So this is a DMR model from Framework Manager, and I'm going to create a report off of that. And we'll do a cross tab. I'll try to be quick about this, but we'll keep it very simple. We'll just do with product line. We'll put revenue in here, and then we'll also put time on the columns. Okay, so if I go and generate SQL MDX here, all of a sudden, all I see is MDX. So I have no idea looking here of what SQL is actually being sent down to the database. So in cases like this, you have a couple of options. One is you could do a JDBC trace, which I'll show in just a moment, or you can go into your validate options for your report. You can switch this to information, click OK, and then validate the report. And now what you're going to see is you'll see that MDX again here in the first entry. But then you'll also get to see the Cognos SQL that's used, that's being sent down. So again, very good for trying to troubleshoot performance issues and, testing the SQL directly against the database. So here's the native SQL that you can test against the database. Okay, so that's another way of getting at the SQL. In older versions, I'm just going to draw your attention to dashboards. I'm not necessarily going to go to the dashboard. I can go to the dashboard. When you open up that serviceability panel, in older versions, I think if you have a dimensional source, you may only see the MDX. We've gotten better now in that we will show you the MDX as well as the Cognos native SQLs. But for the older versions, again, you may want to you may want to copy the object from here. You can do a Control-C, for example. You copy this asset. You can go over to your report. Okay. So you can copy and paste that item in here, and then you can use that validate options trick. If it was a dimensional source and you only saw the MDX, then you could do what I just showed previously. And then finally, the other thing that you can do, I'm just going to clean this up a little bit. Okay, is you can do a JDBC trace. Now, there are a couple of ways of doing it, but I'm only going to show you the new way to do it through the UI. So you can actually go to your manage. You can go to configuration, diagnostic login, and then you can click show all and scroll down to your XQE. Okay, you're going to need to download this topic. Okay, so that downloads this xque.json file, and you're going to edit that in your favorite editor. And the first entry is the JDBC trace. and we're going to change warn to info. There's also the API calls that are made that you can enable. So for more complex scenarios, if development or support requests that, then you can enable that as well. But typically, if you're just doing SQL troubleshooting, all you need is this. Scroll directly to the bottom and give this a more appropriate name so you know what it is that you're using it for in the custom topics area. And you'll save that. And then once it's saved, you'll go back to your portal. And you'll go to the custom topics tab. And you'll hit the upload arrow. Select the file you just downloaded and edited. Okay. And once it's uploaded, you'll enable that and apply. So now if we do, I'll just do a new query. So for example, if I grab product line and throw that on here and I run that, that should just have picked up a JDBC trace at 1120. And so you're going to go to your install location. Go to the logs folder. And if you scroll down to your dataset service log file, that's where the entry is contained. And so you can just scroll right to the bottom and work your way back up because you've just captured this. And so you should see that 1120 timestamp. Okay, so this isn't exactly the easiest to read, but what you want to end up doing is you'll kind of sift through it looking for some SQL. So here I can already see some SQL. Usually it will be preceded by the connection create statement. So this is the actual creation of that query that we're going to submit to the database. And then you'll see the SQL statement again. And at that point, that's where we do a statement execute. And that's when it gets submitted down to the database for processing. And then we'll get, there's a statement execute there. Then we're going to get the result set. And we also want to get the metadata of the result set. So we have not just the data, but also the metadata that comes with that, table names, etc. And then eventually we're going to grab the first row. So we know we got the first row at this timestamp. Then here, we know we got the last row. And once we have that, we will close the result set. We'll close the statement. And then eventually we'll return the connection or the pooled connection. Okay, we no longer need it. Okay, so that's sort of how to sift through and read through the dataset service log. And this is good for timestamps. So you can kind of see what time was it prepared, what time was it sent, how long did it take before we got to the first row, how long did it take before we got to the last row. All that can be gleaned from the timestamps within this file. Okay, and then don't forget to go back and turn off your logging so that you're not unnecessarily bogging down your server. Okay, so to do that, you just click reset and you should be good to go. Okay, so we're going to move on to starting to look at the SQL breakdown. So we already did a very simple test case. So what I'm going to do now is take a look at a very simple, I think we'll start off with, let's start off with the split SQL. So here I'm taking product. So I have a spreadsheet that's just has my products, okay? And what does that look like in the data module? So if we look at the relationships tab here, you'll see that I have this item here called my product list, and that's the spreadsheet that was uploaded. And I've created a relationship from that to a sales fact table. Okay, so if I go back in here and I put product on there, and then I go and grab a measure from the sales fact, and then look at the generated SQL for that. So this is the native SQL. And you'll quickly notice that we have two distinct separate select statements. This is what we call split SQL. So this one is going after the spreadsheet, and then this one's going after what I have in the database. Now, what's happening here is good news in that you can see that there's a bunch of values being passed into the product, into a filter for the product key on the sales fact table. That's because I've already implemented optimization. And I'm going to show you what that looks like without the optimization in a minute. So what ends up happening is that we're going to bring back this data set, but it's going to be far less than what it would have been without that filter optimization. And if you look at the Cognos SQL, well, here's a great example of looking at that scroll bar and seeing, quite a large difference in what's happening. You'll notice the size changes dramatically when we go to Cognos SQL. That's because we're doing a lot of processing locally now, because we are actually going after all the data in the fact table that's been filtered by the stuff that's in the spreadsheet. And then we are joining it together down here. So we're going after the product, and we're summing the sales total, and then we're joining it to that spreadsheet. So that's all done locally. Now, if we had taken off that optimization, which is found here in the relationship, so here you can see it says use unique values under optimization. By default, it is set to no filtering. So if I save this, and sometimes it takes a few seconds to save, and then once it's saved, if I go back and refresh, actually I may have to, I'll save this report and I'll close it and reopen, because sometimes there is caching that happens. So if you want to be very verbose in ensuring your changes are done as expected, it doesn't hurt to just rerun or reopen the report. Okay, so if we go and look at that SQL again, you'll notice the fact table SQL going to the databases has no filter in it. It's quite a bit less SQL. Okay, so this is less. So if we had a billion rows, for example, you could end up bringing back a billion rows to simply tie it to here, which would maybe distill it down to 40,000 or 10,000 or even 100 rows. So you can see the great benefit of using that filter join optimization. Okay, so let's move on to something else. Let's start looking at a basic single fact query. So again, we'll generate the SQL and we'll look at this. So we can see already that this is all being pushed down to the database because it's a single SQL that's being sent down. And you'll notice there's a with clause here, and that is for this thing called goTimeDim view. And it is pulling back. So the reason that this is happening is because in the model, I have more than one table making up my time dimension table. So I'm just going to close this and just quickly show you what that looks like in the model. So you'll see down here I have a goTimeDim. And that goTimeDim is made up of some underlying objects. This is one of the underlying objects. So this goTimeDim and this goTime quarter lookup. So these are two tables. And then those two tables are used in a time dimension here. So this is a table view made up of these two tables. And so because there's a join between them, which there needs to be if you're going to do a table view on them, you then get that with clause because you're going to honor that join between those two tables, especially if you're going up at higher levels of granularity. So going back to the SQL, that's why you see this with clause. So it is doing a reusable SQL block here where the join is implemented between that quarter lookup that we saw and the go time dim. And then you have this final projection list that goes and gets that year, which you saw in the report. And we're aggregating the sale total for that. And then we do the join between the go time dim view that we saw in the model with the fact table, and we group by year so that we can do the aggregation properly. Okay, so that's about as simple as it gets. Unless you had just a simple table, then you would not see this, and I can show you what that looks like. So the actual simplest case would be something like using order method, where I'm not building this up with multiple tables or doing anything too crazy. Actually, I think there's a filter in this one, so I can't use that. I'll have to use something else like retailer. So we'll try this and see if this works. Okay, so this shows a very simplified view. So there's no with clause needed because I can simply select the retailer name and the sale total from those two tables and join them together and group by retailer name. Hence, no with clause required. Okay, so we're going to go back and stick with this year and sale total, and we're going to now add a summary for sale total and then analyze what the SQL looks like for that. Okay, so now it gets a little more interesting. So we still have this same with block that we saw before for the time dimension. And then the query that we saw previously, which was the final projection query, is now here under something called SQ0 query 1. And what that does is it does exactly what it did before. It went and got the aggregation for the total for all the rows for each year. So those are the detail rows. But now we're going to use that query to then further aggregate the final summary row by doing this sum of the sale total found up here over. And now the over doesn't have a partition by, it's just over, open parentheses, close parentheses. So it's doing it for the entirety of the report. And that's why we're getting the summary row. Okay, so if we look at that in page preview, so that's exactly what we're doing. So we're getting all these, and then in that final projection query, we're aggregating each of these into this value here. Okay, so if we move on now to a little more complexity, we will look at, let's go with a multi-fact query. Or actually, maybe I'll show you a tip and trick right now of this particular query. So let's go grab that SQL again. This is what I like to do in order to make life easier to really debug this, especially when you have larger bits of SQL, but we'll use this smaller bit just to prove the point. So I've already, this is Notepad++, and I've already set the language to SQL here to make it easier to read. And what's good about this is if I double click any of these things, I can follow the breadcrumbs of where these things are being used. So I double clicked this with clause block of SQL. So I can see again that it's being used down here. And so you can also double click this to see where that's being used. And then you can see it's being used to final, twice down here in the final projection list. So it's very useful to, and you'll see that in more detail when we use larger blocks of SQL to analyze in just a few moments. Okay, so get rid of this. We'll go back and we'll make this a little more complicated. So I'm just going to remove the summary. And I think what we'll do is we'll look at the multi-fact query. So when I say multi-fact query, what I'm saying now is right now we have an item from time, we have an item from sales fact, but I want to introduce something from sales target fact. And so this is what we call a multi-fact query because they're two different fact tables. They could be at different levels of granularity. In this case, they are. This one is related at the day key. you can see here, day key to the order day key. And this one is related at the month key level. Okay. So if we go back to the report and we go down and add our sales target to this report, and we examine the SQL. So first of all, this is now getting a little bit larger, and there's a lot more going on in here. So I don't really want to analyze it here. I'd like to get some color coding and be able to follow the breadcrumbs to see what's going on. So I'll copy that. And again, if we switch back and forth between that and the SQL, not too much of a difference. They're pretty much doing the same thing. So if we go into our notepad, again, and sorry for the repetition, but it's important to understand what's happening here. So again, we have the same with block here for the time dimension. It's going after year and day key. And then we have something called FS1, which stands for fact stream 1. And that's where we grab the current year, again, from the block above. So again, if I double click this, you'll see that it came from up here. And we sum the sale total again, as we did in the previous query. So this is all the same stuff that happened before, but it's now in a query called FS1. And then we'll go down here and all of a sudden we'll see something with a longer name called data view 1 item normal generated month key. Okay. And we can see that this entire block of SQL from here is being used down here in something called fact stream 2. So this is us going back against the time dimension, but we're doing a simpler or a higher aggregated query just on the month key, and we're grouping by that. So we're only getting 1 month per year for all the months. If we did it up in this query and had year and month key and day key, well, then we would have month key repeating for every day key. And that would explode out the join to the fact table by a factor of how many days there are in a month. And then we come down to FS2. So this is fact stream 2. And so here we can see that we're going after the year, but we know that this is being grouped at the month level, at the month key level. We're aggregating our sales target fact. And then we're doing that inner join from the sales fact table to the time, to that same time query that we just saw up here. We're doing it on the month key from both. And then we're grouping it by the current year. And then the final magic that happens is you'll see this coalesce statement. So what we're doing now is we're stitching together fact stream 1 and fact stream 2 in this final projection list. And we're saying, go get me the first non-null value. That's what the coalesce does. So if I have something in FS1, I'll use that. If I don't, get it from FS2. If there's none for either, we'll handle that later here in the is null in the join condition. And then we basically bring back these two totals, the sales total and the sales target total. And they've already been aggregated up here. So we're just bringing those back. These are the detail rows for every year. And we do a full outer join on that so that we don't lose data on either side of that stitch query. We don't lose data from FS2. We don't lose data from FS1. Okay, so now let's make that even more complicated. And we'll now add a summary to that and grab that SQL. Okay, without belaboring the point too much, a lot of this stuff is the same, but we'll focus on where it starts to differ. So now we see something here called SQ0FS1. So just like I showed before when we had that single fact query, you get this introduction of another subquery that goes to get the detail rows. It's aggregating the detail rows for the year. And then you have your FS1 that now has those detail rows that you see right here on line 28. And then we're getting the summary row. So we're summing that sale total, which we find up here. over the entirety of that query. And then we go after, again, the time dimension again to go get the month level, the month key level. And then we have, this used to be FS2. It's now the subquery for FS2. Same concept as the one above. Here's the final projection list for the FS2. And then, as we did before, we coalesce them all together. So the difference that you'll notice in this coalesce now is that you have, again, your detail rows here. So that's FS1 sale total, FS2 sale total as before. But now you'll see this min where we're going to get FS2 sale total. Now that's taken from up here. And then if we double click this guy, you'll see that's taken from here. So the reason we're going to get the min is because these guys are going to repeat for every one of these rows. We only need one of them for the summary row. And you could get the min or the max. It wouldn't matter. We opted to go with the min route. So you just need that value once for the summary row. Okay, we definitely don't want to aggregate that. We just want the one value. Okay, so that is the multi-fact query. So we're going to move on and look at what non-conformed or non-shared dimension, if we introduce that into the query, what that looks like. So again, I'm going to remove this summary here just to keep things a little simpler when we do it. So if I go, when I'm talking about a non-shared, I think I might have mentioned this, but if not, just to be clear. So the current query that we have is time, sales target fact, and sales fact. And what I'd like to do is introduce something called order method, which is only related to the sales fact table. So this is non-shared or a non-conformed dimension. And this is important because it can introduce another level of granularity in the query, and it can explode out the values that you see for the non-shared fact table. So if we now drag order method into here, and we'll go take a look at that SQL. Okay. So just even before I move this over to the notepad, I'm already noticing something right here in the subquery for the order method. And what I'm noticing, because I didn't expect to see a subquery for that, so I see that there's a filter in here. I know that I didn't put a filter in my report, so this has to have been done in the model. Okay, so this is another tip, or when looking at the SQL, anything that you've seen here that you do not see in the report design or the dashboard design, that means that it was done in the model and or done at the database, perhaps in a view, for example, or a stored procedure or a function. Okay, so these are things to be aware of. So this now has something in it that I didn't really expect. So I'm going to save this. I'm going to close this. I'm going to go back to my order method, and I can see already that there's a filter on there. It was probably done for design purposes. So I can manage the filters, and I can look at that and say, remove that filter. Okay, so now I no longer have that. So I'm going to save the data module. Then we'll open up that report again. So that's been validated against the latest package. Now let's see what the query looks like. Okay, so now I don't see that order method and the filter is gone. So that's good news. So let's copy this and take a look at this in Notepad. All right. So dissecting this, again, everybody's now familiar with this first block of SQL, our first fact stream, except now we're introducing order method. Okay, because order method does apply to the sales fact table. And so we join everything together here. So now you see two inner joins as opposed to one just to the time dimension. So we're tying all that together in the FS1 stream. Then we have our separate time dimension query here for our FS2 at the month level. And you'll notice here, there is no order method in the query because it does not apply. And then we simply tie it all together. Okay, so that's an important distinction to make. And so if we go back and run this, look at the page design, okay, you're going to start to notice repeating values. So what I'm going to do in this particular case is I'm going to do a grouping here on year. Okay. And what I'm also going to do is I'm going to select these two measures and I'm going to do a sum on them. Okay. So what's important to notice here is you'll see the repeating values. This order method is introducing a level of granularity that does not exist for sales target. So again, at the design of the product, a choice had to be made. Do we repeat the values and then just don't double count them? Or do we just show it once? The decision was made to repeat it across and not double count. Well, we wouldn't double count it provided that, you know, the model is configured correctly. And I'm going to show you that in a minute, what it looks like when you don't do it correctly. But because having it appear just once can also be confusing, because then you would think, oh, well, this value only applies to email. So this sort of gives a visual indicator that, you know, that this is really at a different level of granularity because it's repeating. Okay. I could go over this SQL. In fact, I am going to capture this SQL because I do want to compare it to what it's going to look like when we don't have the model configured correctly and we get double counting on that sales target measure. So I'll copy this. All right, so I don't think that we need to necessarily go through all of this. It's more of the same. Again, you have your fact streams. You'll see that you have the subquery now for the fact stream 1. Again, you know, this has the order method in it on line 16, whereas in fact stream 2, the subquery for fact stream 2, we don't have that. And then we coalesce everything together. Okay, and now you're seeing that we are actually partitioning things in this particular case because of the different levels of granularity. Okay, so let's take a look at what happens if we don't have things configured properly in our data module. So the reason that these numbers came back correctly is something called, in Framework Manager, we call them determinants. And in data modules, it's something we call column dependencies. And so the shared dimension between these two is time. So we know that the aggregation was done correctly because time was configured correctly. So if we right click on this or click the 3 dots, you can see specify column dependency option here. And then you'll see that we actually have something defined here. So we know we have all these identifier, the key, the day key, the month key, the quarter key, and all the attributes that go with each of these keys. So this is an actual hierarchy within the time dimension. And so when you bring in month, for example, we will know to group by and roll up at the month level, but if you have a relationship to the month key. Then that's why you saw that extra subquery for the time dimension at the month key level as opposed to the day key level. So if I remove all this, so I'm just going to delete all these column dependencies. Okay, so you'll see these warnings that should go away now because there are no column dependencies. When you see those warnings, it means your column dependencies are not complete. You have orphaned items. So everything in the table has to belong to some level. Okay, so we'll save this. Just keeping an eye on the time here. We'll go back to the report. Now we'll see if a refresh will capture this or not. So I'm going to take a quick look at this. No, I'm going to need to relink it, I think. All right, let's take a look. And if worst case, that looks better. All right, so let's copy this. I'm going to bring this into a new tab in Notepad++. And then I'm going to want to use the compare tool. I'm just going to do a quick double check here. So we'll compare these two. Okay, so instantly looking at this now, without the column dependencies, it's what I said before. This is the original one where we just had year and day key. In this one now, we're doing everything. We're grabbing month key in here as well, which means, again, month key repeats for every day key. So that's one difference that you're going to see in the SQL. And this is why doing a compare and before and after, these are this is a good example of how to use Notepad++ or your favorite editor to do a compare. Okay, so now we come down here. So we see this separate query for the time dimension is missing on this side. Okay, and then, you know, these queries are similar, except this one is pulling from that additional month key time query versus this one is going back to the top. It's going all the way back up here to grab the month key or the current year from that particular query. Okay, and then the rest is the same. So we now know that we are basically going to double count our sales target values for every day in that particular month. And so if we run this, well, of course, it's cached. So I think I might have caching on here. So let me just turn that off. No, caching is not on. Let's try one more thing. Okay, that's better. So when we run this report without the cache on, you'll notice that the numbers are highly inflated now. And so anybody who knew their data would look at this and go, well, this is an insane number. We're way, way over targets. And then the overall is just an astronomical number. It was 4 billion. This is 127, some odd. So, so again, using our deductive reasoning, using our knowledge of how to model correctly, and looking at the SQL, we now understand why these numbers were inflated. And then you would use your knowledge of modeling to basically apply those column dependencies, bring them back, and then get the correct value or the correct rollups. Okay.
Thank you for watching.